Hi friends, so in the last class we discussed problems from the ray optics. So in this class also we are going to discuss about the problems from the ray optics. Today we are going to discuss about the prism based problems. So in this class we have a problem, a glass prism of refracting in angle 60 degree and a refractive index of 1.6 is immersed in water of refractive index 1.33. Calculate the angle of minimum deviation. So my angle of minimum deviation, it's depending upon the refractiveness of the medium. So we know the generalized formula for refractive index, the angle of minimum deviation. So minimum deviation delta m equals to mu minus 1 into a. So this a is my angle of the prism, mu is called your refractiveness of the medium. So whenever your ray of moving from one medium to another medium, there is a deviation. If the refractiveness of the medium varies, my angle of minimum deviation also will varies. So in this case, the given data, so I can simply write my A equal to 60 degree, and then I just want to find the refractive index of the glass when it is placed inside the water. So the refractiveness of the glass with respect to water. So I can simply write mu g with respect to air divided by mu water with respect to air. So this is nothing but a value of 1.6 by 1.33. So refractiveness of the glass with respect to refractiveness of the water. So when it is immersed inside the water. So I can simply write, so we have a minimum deviation formula here. So from the Lenz law I can simply write, so so sin I by sin r equal to a constant, right? So r I can simply write refractiveness of the glass divided by refractiveness of the water. So sin I can simply write sin of a plus delta m by 2 divided by sin of a by 2 equals to 1.6 by 1.33. So this is the generalized form. This is an equation from the Snell's law, right? So what I am going to do here, I am going to substitute this values here. I am going to simplify this. So I just want to find my delta m here. So sin of a plus delta m divided by 2 equals to 1.6 by 1.33 into sin of a by 2, sin 30. So I can simply write sin 30 degree. So I can simply write 1.6 by 1.33 into 1 by 2. So if I solve this right inside, I am getting 0.56. So sin a plus delta m by 2 equals to this. So a plus delta m by 2 equals to sin inverse of 0.56, where we will get sin in the sin function, we will get 0.5 only in the around 30 degree. Yeah, so sin 30 is going to be 1 by 2. So this is 1 by 2 is equal to 0.5. So here 0.56, it's around 0.5, right, around 30 degree. So in the problem itself they given sin inverse of 0.56 equal to 34.3 degree. Most of the problems they won't give this, so you have to approximate. So using logarithm or natural sines and natural cosines, you can solve the problem, but usually we don't have enough time to solve this. Okay, so try to approximate it. So sin, this is going to be 34.3 degrees. So listen carefully. So I just want to find my delta m. If I bring this 2 here and then delta m, after simplifying this, I am getting the value of 8 degrees. See, if I multiply this 2 by here, I am getting 68 minus 60, I am getting approximately 8 degrees. So my angle of minimum deviation of the prism, of the given prism, when it is immersed inside the water, there is a minimum deviation occurs approximately around 8 degrees. So we have a next problem here. One face of a prism of refracting angle 30 degree and a refracting index 1.414 is silvered. At what angle must a ray of light fall on the unsilvered face so that after refraction into the prism and reflection at the silvered surface, it retraces its path? Okay. So first I will explain the question. So listen carefully. So whenever the ray of light moving from one medium to another medium, there is a deviation. So I have a prism of refracting angle 30 degree, right? So one face is silvered, it's polished, so there is no escape of light from here to here. So this is my normal of this surface. This is my normal of this surface. I can simply write n. So whenever the ray of light coming from some source which will hit which an angle of incidence is going to be I. Next, whether I can simply take this my I1. Okay. So this is my angle of incidence in the first surface. So it gets deviated here, which makes an angle R1. So the angle of incidence in the second phase is going to be I2, angle of refraction in the second phase is going to be R2. Listen. So in this case, when the ray of light, it retraces its path. So which is retraces the path when it's hitting on the second surface, which means the ray of light which will hit the surface normally, which means the angle from here is going to be 90 degree, which will hit by system normally, which means my normal also on the same plane, my ray of light incident also same plane. So I can simply write my I2 equal to 0. The angle of incidence of the second phase is going to be 0 because it's act as a mirror. So when the ray of light is normal to the plane, then only it's retraces its path. Which will make some angle theta, the angle of reflection will be there. But in this case, my angle of reflection also is going to be 0. So from the prism, we know my R1 plus R2 equals to what? A. So my R1 plus 0 equals to 30 degree. So my R1 equals to 30 degree. So from the given condition, we are able to find my I2 0, R2 0. From this given data, I can find my R1 equal to 30. Next, I am going to use my Snell's law. Okay, so I can using Snell's law here. Am I right? Sin I by sin R equals to refractive index mu. So in this case, refractive index is given here. So I may write this equation: sin of I1 by sin of 30 degree R minus 30. U is going to be 1.414. So I just want to find this I. So sin of I1 equals to 1.414 into sin 30 degree. So 1.414 into 1 by 2. So I just want to, if I simplify this value here, I am getting sin of I1 equals to sin inverse of 1.414 into 1 by 2. Simply right here 1.414 is nothing but what? Root 2. So I can simply write sin inverse of root 2 by 2 is going to be sin inverse of 1 by root 2. So 1 by root 2. Where will get 1 by root 2 in the sine function? 45 degree. So my I1 equals to 45 degree. So the angle of incidence in the first phase I1 should be 45 degree with respect to the normal. Then only the refracted light from the first phase which will hit the second phase and which will retrace its path. Okay, so the angle of incidence is going to be 45 degree. So we have a next problem. A small bulb is placed at the bottom of a tank containing water to a depth of 80 centimeter what is the area of the surface of water through which light from the bulb can emerge out? Mu equal to 1.33. Consider the bulb to be a point source. Listen, we have a container with a bulb. Okay, so I will explain the diagram here now. So I can simply take. So this is my container. Okay, we filled with some water. So if I have my point source here, it should be S, it's my source. So what's happening? Whenever the ray of light moving from denser to rarer, it's moving away from the normal. It's moving away from the normal, right? So if I look at this object, the source from here now, so which is parallel to my normal, so I can see the source easily. So if I look at from here, there's a deviation. If I look at this from, so there's a deviation. So when the ray of light hit the surface with a critical angle or more than critical angle, there is no emergence of light from denser to rarer. So this condition is called total internal reflection. Okay. So when ray of light moving from denser to rarer, the angle of incidence which is greater than the critical angle, when my eye is greater than IC critical angle, there is no refraction, only reflection is there. So when my eye equal to IC, then there will be a no reflection as well as refraction. So this condition is very, very important condition. This condition is called total internal reflection. So what's happening here? I just want to find the finite area, which means the light will form a area here, which means the light is not escaped, it's not reflected. So the angle of incidence exactly at critical angle. So listen carefully here. I'm going to consider the light which will form a area here. So with radius r. So the height of this would be h. So the point from this point to this point is going to be A. This is going to be point B. So this is my radius of this area formed by the light source, because the angle of incidence, if we take the normal of this point, the angle of incidence should be IC. Here also the angle of incidence is going to be IC. So this is also IC and this is also IC. So when your angle of incidence equals to critical angle, there is no reflection as well as refraction. The light which will form a patch on the surface of the water. So we try to find the area of this patch. Okay, so we have a generalized formula. So from the total internal reflection, sin IC equals to 1 by mu, right? So we have a, so from this expression I can simply write my tan theta. What is my tan theta here? Opposite by adjacent side. So I can simply write what is my tan theta. Tan IC equals to OA by OS. So my OA should be R, S is OS should be H. So tan IC equals to R equals to H into tan IC, right? So from the total internal reflection, sin IC equals to 1 by mu. So I can simply write my sin IC equals to 1 by 1.33. This is going to be what? 3 by 4. I can simply write my cos IC, because I just want to find my tan IC. To find my R, I should know my tan IC. To find my tan IC, I should know sin theta by cos theta. So I can simply write my cos IC using sin square theta plus cos square theta will be 1. So cos is going to be square root of 1 minus sin square IC. So I can simply write square root of 1 minus sin square is going to be 3 by 4 times your root square. So it's 7 by 4. So this is my cos IC. So this is my equation 1, and I can simply write my R equals to H into Sin theta by cos theta. Sin is nothing but my 3 by 4. Cos equal to be 4 by root 7. H into 3 by root 7. Sorry, 3 by root 7. So I just want to find the area. Area equals to pi r square. So if I substitute this value here, pi into h square into 9 by 7. So h I know is going to be approximately 80 centimeter. So pi into 80 square into 9 by 7. So if you solve the problem, we can get the value of the area, 2.6 meter square. So if you want to write this in terms of meter, so I have to write this in terms of centimeters. It's going to be 0.8 square. Okay, so if you are writing the value in terms of centimeter, you can take 80. So for meters, I just 80 into 10 power minus 2. So I can simply write 0.8 square. So if you simplify this, I am getting the value of 2.6 meter square. So this is how we solve this problem. So the condition is the total internal reflection. So I just stop at this point. If you like this video, share with your friends and subscribe to the channel for the more content. We'll meet in the next video. Thanks for watching.